We want to maximize the area of this window that's a rectangle with an equilateral triangle on top. We have this lovely hint about the area of an equilateral triangle. Since this bottom is x, this is also x, and so the area of this triangle will be represented by root 2 over x squared. The total area of the whole window is the rectangle, x times y, plus the area of that equilateral triangle. And the constraint is that the perimeter has to be 20 feet. So the area, the perimeter, this orange part, has to be 20 feet. Since this is x, these are x, this is equilateral, this is y, this is also y. So in general, the perimeter would be 3x plus 2y. That cannot be more than 20 feet, so that has to equal 20. And I will now make the choice to solve this for y. I can solve it for x as well, but I'm going to solve it for y. If I solve the constraint for y, y will equal 20. I'll subtract that 3x over and then divide both sides by 2. And I'll use the information from my constraining function to plug into the area function so that the area is all in terms of one variable. So the area will become x times that y value in terms of x plus the other part of the function. This is what I want to maximize, and here's where, instead of doing all the work I did on the PDF file, just go ahead and bust out the graphing calculator, graph this function. I did that earlier. The graph looks something like this. I'm using this window from -1 to 20, from -2 to 40. It took some playing around to get there. So my graph looks like this. And I can go ahead and use the second calc max feature to find that if I go a little to the left and a little to the right, and then make my guess, that the x value would be equal to approximately 7.886. If you look at the exact answer that I did with all the calculus stuff, you'll see I get the same exact value. 10 over 3 minus root 3 does equal that same thing. So x is approximately, what did it say? 7.866. Which means the y value is going to equal whatever 20 minus 3 times this value divided by 2 equals. Good luck.